Okay, so we're going to talk about the periodic table. We have a periodic table on the wall here. The periodic table is a chart of the elements, and they're arranged in a particular way. This textbook doesn't go into the history of it much. The periodic table originally came about because a guy named Mendeleev was looking for patterns and trying to figure out how to organize all these elements that had been discovered. And so the periodic table organizes the elements so that they have similar chemical and physical properties in the vertical columns. So what we need to know is there's different parts of the periodic table, different names for those parts, and we need to be familiar with those. So vertical columns. The vertical columns in the periodic table are called groups or families. Those two words are used pretty much interchangeably. Elements in the same group, in the same column, have similar properties. They have similar physical properties often and similar chemical properties. So just like people in the same family have some similar characteristics, right? If you look at my kids, you see they're all from the same family. They just, they have that look to them. They all look similar. We designate those groups. There are two different numbering systems. The periodic table on the wall shows both of them. The newer one is just numbering them 1 through 18. I don't like that one. I think the older one that has the letters with it, A and B, is more useful. And so that's the one I tend to use. We're going to look at a periodic table on the screen here pretty soon. And some of these columns, some of these groups or families have names that you need to know. The horizontal rows are called periods. And those are just numbered from top to bottom, 1 through 7. And then the table also gets divided into representative, also known as main group elements, and transition elements. So let's look at an actual periodic table here. So here we have the two different numbering systems for the groups. The top one here is 1 through 18. The bottom one, this is 1A, 2A, 3A through 8A. And those are the numbers that I find the most useful. And so those are the ones I'm going to refer to. The periods here are numbered. Now, this table did that funky thing. Here, let me fix this. Black. So here we see hydrogens kind of floating around in the middle. Hydrogen really belongs over here. And that was period 1. Hydrogen, we'll find, is an exception to many rules. He's like the baby brother of the element family. He gets away with breaking all the rules, right? And it's, oh, he's so cute, and they just let him get away with it. In some ways, hydrogen belongs in this family, group 1A. In some ways, it belongs in group 7A. In some ways, it doesn't really belong anywhere. And so sometimes you'll see a periodic table where they just kind of stick hydrogen out by himself in the middle. But usually you see hydrogen over here. So these are the periods 1 through 7. And then we have the names. So this first group, those are called the alkali metals. Now hydrogen is not a metal, it's a gas. And so technically hydrogen is not an alkali metal. But lithium, sodium, potassium, rubidium, cesium, francium, those are all alkali metals. Group 2A, these are called the alkaline earth metals. Group 7A has a special name. These are called the halogens. And group 8A, helium and his friends, these are called the noble gases. Those are names that you need to know. Then we also have the representative and the transition elements. What would be a good way to indicate that? So these guys and these guys over here, these are all representative or main group elements. So these are the groups that stick up. Those are the main group elements. Their properties are more predictable. And then we have the transition elements. And those are these guys in here. These are the transition elements. They tend to be less predictable. But you need to know those divisions in the periodic table. These guys we don't refer to very much. These are called the inner transition elements. They really belong in here. Now on the wall, we have a periodic table that's arranged the way it really should be arranged, where these inner transition elements are actually inserted here. If you notice on the periodic table, barium is number 56, lanthanum is number 57, cerium is 58. There's a gap here, lanthanum, and then this is hafnium. There's a gap if you go, because this is supposed to be up here. Why don't we show the periodic table like it is on the wall? It's too wide. It doesn't fit on a piece of paper very well. That's really the only reason. It's just too long. It's inconvenient. These elements down here are uncommon. Many of them are man-made, and we don't use them very much, and so they're just not that important. And so we usually see the periodic table like this, with these kind of almost as a footnote at the bottom. But they do belong in this little gap right here. Any questions? The periodic table is an awesome thing, and a chemist just would never do anything without having access to a periodic table. So after today, anytime you take an exam or anything, we've got the periodic table. You don't memorize the whole periodic table. Okay, so we can also categorize elements as being metals, nonmetals, or metalloids. So metals, that's a word we're familiar with. Give me an example of a metal. Steel. Now, steel isn't an element, but it is a metal. How about aluminum? Is that a metal? How about wood? No. Oxygen? No. So metals we're familiar with. And in chemistry, the word metal means pretty much the same as it means at home. It's a good conductor of heat and electricity. They tend to be shiny, malleable, and ductile metals. Then there are nonmetals. Nonmetals are things that are not metal. Okay? Nonmetals are generally poor conductors. The nonmetals are less, they're more diverse in their properties. Because we have oxygen being a nonmetal, it's a gas at room temperature. Then we have something like sulfur is also a nonmetal, and it's a solid at room temperature. So they're less predictable, and they're generally poor conductors. And then we have some that really just fall between metals and nonmetals. And these are called metalloids, or sometimes they're called semi-metals, because their properties lie between. So what is a humanoid robot? Anybody watch science fiction stuff? A humanoid robot isn't human, but it looks and acts human in some ways, right? It's kind of between a robot and a human. And so a metalloid is kind of like a metal, but kind of not. So on the periodic table, in this example, all of these purple elements, those are the metals. And the yellow ones are the nonmetals, and the metalloids are the green ones in between. And so we should be able to look at a periodic table and identify, just by looking at the periodic table, is this element a metal, a nonmetal, or a metalloid? Well, they're not all color-coded, are they? The one on the wall is not color-coded in this way. There's a stair-step line here. This is the division between the metals and the nonmetals. And I don't think a periodic table is complete without that stair-step line. This one on the wall, if you look closely, the stair-step line was made with tape. because it didn't come from the manufacturer with the line, but we felt it was important enough to get out some nice blue tape and make the line. So you need the line. The line is the division between metals and nonmetals. The semi-metals are all touching the line. The one exception is aluminum. I bet you have an aluminum pot at home in your kitchen. Is aluminum a metal? Yeah, we know that from life experience. Aluminum is a metal. So the semi-metals or metalloids are all of the elements that are directly touching that on a side, except for aluminum, which is a metal. Any questions?